Hi, in this video we're going to talk about solving for the intersection between lines and planes, and specifically we're going to look at the first two targets that you see on the board right now, solving for the intersection between two lines and solving for the intersection between a line and a plane. I'm sorry I can't be there with you. If you have questions about it, feel free to seek me out, and be happy to work with you on any of this material and anything else that you need help with. Okay, so we're going to begin with thinking about two lines, and I want to think about with you the ways that lines can be related, right? And so, typically when we think about two lines, there are a few different cases, right? There's this trivial case where they could be the exact same line, right? So we say that the lines coincide. But again, that's a pretty trivial case. And we don't really need to talk too much more about that. These two lines would have not necessarily the same equation, but would produce the same line. Now, when we think about y equals mx plus b, those kinds of things, then those kinds of lines would have the same equation. But when we move into vector land, we could have different starting points and different lengths of the direction vector. And so the lines might not look the same and might not be obviously coinciding just by looking at the equations. But the second way they can be related is that they could be parallel, right? And we're not just listing these to list them. I want you to be thinking about what these different ways mean for the equations that we're looking at, right? So, here are two intersecting lines. I meant to show you the parallel ones. Let me do that. So here are two parallel lines, and I want us to think about what in the equations is the same, right? And think about our forms, right? So we've got our sort of R equals form, right? R equals A plus lambda V. And when we look at those parallel lines, what can we say about the two equations that represent those lines? Okay, and we'll get to that. And then 3, of course, we can have intersecting lines. Okay. And again, what does that mean in terms of the equations, right? Well, let's think about the parallel lines to start with. These two lines never touch. They don't share any points. So the A point certainly can't be the same. However, they share the same direction, and so we remember that that's represented by the V vector, right? So in these two lines, vector V is the same, right? Intersecting lines, right? These share a point, and so it could be the case that they have the same A point, but it doesn't have to be, right? The starting point could be down here for this line, and the starting point for this line could be over here. And so, we're not necessarily going to be able to see from the equations that these intersect. Now, you might say, well, okay, they might not have the same starting point, but if they have a different direction vector, then they're going to have to intersect, right? And that's a good thought. However, what if these lines aren't in 2 dimensions, but in 3 dimensions, right? And so these two lines don't intersect at all, right? And so beyond, they seem to intersect here, and we'll be talking about that in a little bit, but beyond the 3 possible choices here, we have a fourth when we're in 3 dimensions, and that is that these lines are skew. Okay, you have to forgive my writing here. I'm writing on a tablet I'm not used to. But so in this case, that's what we have, right? We've got these 2 skew lines that are not parallel because they don't go in the same direction, but they also don't intersect, and so we call those skew. Okay, and so Hopefully that is very clear in this picture. I'll come back to that. And so it's hard to tell sometimes whether or not two lines are intersecting or skew. Okay, these two are the tough ones to tell. Parallel is easy. They're going to have the same direction vector. If they coincide, that's pretty easy too. They're going to have the same vector, and the relationship between their two starting points will be that they are separated by a multiple of that direction vector. But these ones are tough to tell, so we need to figure out how to do that. So let's take a look. How are these lines related? Well, first thing you want to do is realize I need to know the direction vector. That's going to tell me a lot. If the direction vector is the same, I know it's either 1 or 2. They coincide or they're parallel. If it's different, I know it's either 3 or 4. They're intersecting or skew. So again, we go back to our forms and we think about what do the forms tell us? How do we gather the information from the forms? So in this equation, our v, let's call it v1, is the vector I plus 2j plus k. How am I getting that? I'm getting that from the denominators of the Cartesian form, right? Okay. Same thing over here. This is Cartesian form. V2, I plus j, and then since this is a negative, really this is z minus 3 over negative 1. This would be minus k. Okay, so I've got the two direction vectors, and I look at them and I realize they're not the same. Not only are they not the same, they're not multiples of each other, and so these two lines cannot be neither the same line nor parallel to each other. And so they're either intersecting or they're skew. So how do we tell if they're intersecting or skew? Well, you know, in earlier algebra courses, you would just have these two equations in y and x, and you would solve both of them for y maybe, and you'd set them equal to each other and solve for x and then plug back in and get y, right? It's similar here, it's just that we've got 3 variables to deal with instead of 2. And so the best form to do that is to recognize that this form, Cartesian form, as well as vector parametric form, are really 3 equations in one, right? I mean, that's pretty clear here. We've got the 3 pieces, but we've got 3 equations in one because we've got equations for x, y, and z all embedded in here. And so what we want to do is break that out, right? And the form to do that in is parametric form, right? So we want to use parametric form. That is my go-to form for solving for intersections of lines, okay? So let's write that in parametric form. First one, x1 equals 3 plus lambda 1, okay? Again, make sure you know your forms. y1 equals negative 1 plus 2 lambda 1. z1 equals negative 3, excuse me, that's not right, 3 plus negative lambda 1. What am I talking about? I'm looking at the wrong equation. Try that again. I was looking over here. I was right the first time. This is negative 3 plus lambda 1. Okay. x2. We've got 1 plus lambda 2. y2 is negative 1 plus lambda 2. And z2, this is the one, is 3 minus lambda 2. Okay? Now we can use these to solve, you can use any 2 of these to solve for the third. So let's sort of talk about that, right? If I look at this picture, these 2 lines were skew, but they look like they intersect because I'm looking at it from a certain point of view. The point of view I'm looking at is looking down on the xy plane okay? And so these cross in the xy plane if we sort of project them down to the xy plane, right? They meet at the point 0, 2. Well, that is solving for the location where the x's are the same and the y's are the same. But it's not necessarily the case, and in this case it isn't the case, that the z's are the same at that point, right? So our strategy here is to pick two of the coordinates, in this case x and y, solve for the lambdas that make those two the same, and then check to see if at that same pair of lambdas the z's are the same. In this case, in my picture, they're not, right? We could do that not just with the xy, but we could do that, for instance, with the yz, right? So this is the yz plane, okay? And here's the point where y and z are both the same. But x is not the same at that point, right? So, we can also do that in the xz plane. You can't really see it in this one because they don't intersect in the picture in the xz plane. It would be up over here somewhere, okay? But we can do that for any two of the three coordinates and then use the lambdas that we get from that process to see if the third coordinate is the same as well. If it is, they intersect. If it's not, they're skew, okay? Hopefully that makes sense. So let's just take, for instance, x and y and get equations from that, lambda equations in terms of each other. So from this pair of equations, we're going to get that, I'll solve for lambda 2. We're going to get that lambda 2, just subtract 1, set these equal and subtract 1 from both sides, is 2 plus lambda 1. Right? I just set the two x's equal, subtracted 1 from both sides, got lambda 2. I can then use that as a substitution into either of the other two. Let's substitute it into y, and we're going to get that negative 1 plus 2 lambda 1 equals negative 1 plus, and then the quantity 2 plus lambda 1. Okay, so I'm going to do a little mental math here to prevent me from overwriting, taking up too much space. But if I do this substitution, I'm going to get 1 plus lambda 1 on this side, 1 plus lambda 1. And I will then subtract lambda 1 and add 1. So 1 plus lambda 1 produces a 1 lambda 1 on this side. Lambda 1 equals 2, looks like. Okay, could double check that. Lambda 1 equals 2, which makes lambda 2 4, right? Okay, lambda 1 is 2, lambda 2 is 4. We can double check that that satisfies the x and y coordinates. If I plug in lambda 1 here, I get x is 5. If I plug in 4 here, I get x is 5. Looks good, right? Same thing for y's. If I plug in 2, I get 3. If I plug in 4, I get 3. Looks good. Now we check the z's, right? We're guaranteed, almost guaranteed, to get a solution in x and y. The only way we wouldn't is if one of these lines doesn't move along either the x or the y direction, right? And then we might not get a solution in x and y. But now we check the z's, right? Plug in 2, we get negative 1 here. 3 minus 4 is also negative 1. So they are the same. So these lines intersect. Okay? They intersect at the point, 5, 3, negative 1. Okay? And that's basically how we do that. We want to move into parametric form and then solve. We can do the same thing here, right? I've got a slightly different setup. I got this form that I've never used, right? Just to kind of throw you off. And then Cartesian form, right? This is in the notes, so you can look at that and try to follow along, but we want to follow the same process.